Okay, howdy. Good afternoon. As most of you already know, we have an exam on Wednesday, and the material that's going to be included in the exam, we already finished the material that's going to be included in the exam. And the material was until last lecture, which was Wednesday's lecture. In that lecture, we cover up to the normal distribution. We started discussing the exponential, but that material about the exponential distribution is not going to be included in the exam. Okay, so before we go to the review for today, remember to pick up your homework. This is homework number 6. It is already graded. The grades are also posted online, so you can check your grades. You should be able to see all the homeworks, all the labs, and the grades for the first exam. So please be aware, check on track that all your scores are the ones that corresponds to your grades. You can leave it there until the end. Yeah. So what else? Any questions, comments? I haven't posted these slides yet. Decided to go through the review before we get to post this online. But essentially, what you're going to see here is what you have on your notes. So let's get started. So the exam again is on Wednesday, October 31st. You're going to have the time of the class or the class period to work on your exam. Again, I'm going to prepare two different exams. So you know the drill already. I'm going to tip you in different lines, and I'm going to pass the exams. The exam is prepared for an hour, so you should be able to finish within an hour, even though you have an hour and 20 minutes to complete the exam. Okay, so in terms of the format of the exam, we have part 1. Again, you're going to have 10 multiple choice or true or false questions. Last time, I decided to have all of them were true or false. This time, you might see some multiple choice questions. Okay, but it's basically the same type of question. You're going to have 10 of those. And the second part, you're going to have 4 problems, similar to the ones we have discussed in class, and also the ones you have seen in the homework. You can also have some description problems, just like we did on the first exam, in which I asked you what is a random variable and what is the difference between a continuous and discrete random variable. So you can see one of those problems as well. Any questions about the first part? Second part, again, 4 problems, 4 to 5 problems, depending on the length of the problem. I haven't prepared the exam yet, but again, just think about the first exam. You should expect something similar. In terms of the material, so we have material from the 3rd chapter, which was random variables and probability distributions. And this is basically the last part of that lecture, in which we discuss joint probability distribution for discrete and for continuous probability distribution. Okay, so it should be able to find a marginal distribution from a joint for discrete and continuous random variables, and it should be able to compute probabilities for joint distributions as well. For the material on mathematical expectation, from that chapter 4 on your textbook, I only covered part of the chapter. So basically, the lecture focused more on the mean of a random variable, how to compute the mean of a random variable, how to compute the variance and the covariance for a random variable. Okay, and today I basically, what I did was, in order to complete the review, I choose some of the problems from your homework, and we're going to discuss some problems from your homework here in class, just to give you an idea of what type of problem you should expect in the exam. Okay? Yes, sir.
Well, didn't you say that a lot of the tests will continue this normal?
They say mostly about 33% of the exam. Yeah, but it is also material covered. No,
I just wanted to.
yes, yes. So that's something I mentioned in class. Yes. So chapter 5, discrete probability distributions. So these are the lectures that were posted online. In basically, we covered 4 different distributions: the binomial, the hypergeometric, the negative binomial, and geometric distributions, and finally the Poisson. Then all these distributions belongs to the discrete probability distribution family. This is a type of distribution in which you have to be able to read the question and understand what type of probability distribution you're going to use. So, for example, if I ask you for the number of success of the number up to the first success, you should be able to know that that belongs to a negative binomial or to a geometric distribution. Which one? The number up to the first success, is it a geometric or negative binomial? It's a geometric. What about if you have a sample and you choose a group of those samples and you want to know how many success you have from that small sample? That's a hypergeometric. Okay, so we're going to discuss some of those problems here in class today, and I want you to be able to identify what distribution you should be using for each type of problems. And finally, the last chapter, which we started in class, was the continuous probability distribution chapter. And here we discussed the continuous uniform distribution and the normal distribution. Okay? And for that last part, here we discuss how to transform the normal distribution to a standard normal distribution with a mean of 0 and a standard deviation of 1, and how that simplifies your computations. Okay, so you should be able to use the table from the normal, transform your normal distribution to a standard normal distribution, and use the C table to complete your exercise. Okay, so in terms of preparation for the exam, you need to, if you want, you can read the chapters 3 to chapter 6, those sections that were covered in class from your textbook. Study the lecture slides and the homework. Yes, sir.
You recommend reading the chapters, or recommend going to the slides? Because I've noticed that a lot of the information in the chapters are more either in depth or they have a different definition. You explain it, I think, better, but it explains it a certain way and then it emphasizes on certain things that are not. I don't know if they're going to be included in the test or not. So.
Yep. So if you're reading the textbook, again, you can refer to the first slide of each lecture. There I list the topics that we are including in the lecture. Those are the ones that you should focus. So, for example, if you go to the textbook, you can see, let me go back here. When I highlight these bullets, this is basically the information that I'm covering from the chapter. So if you see something that is not within these bullets, that means that that's something that I'm not considering for the purpose of the lecture and for the purpose of the exam.
The thing is, okay, real quick, that in the book it probably goes way more in depth than your slides will reveal. So what I'm saying is, are we going to read information that is probably too much, or we just, I guess, use your slides as like a foundation pinpoint what?
Yeah, I would say if you're able to understand everything that is on the slides and you understand the problems from the slides and the homework, it should be fine if you
What
put
do you
this.
explain?
Yeah, but the book will help you in terms of if you want to go a little bit more in depth on the topic. Okay? Any other question? Okay, so you can also bring a handwritten sheet or formula sheet for this exam. I'm going to provide the tables. So the tables for the normal, the tables for the binomial, those tables I'm going to be providing them for the exam. But you should bring your formulas in order to solve the exam. You can also use a calculator. Okay. The exam is closed book and notes. You're allowed to use your formula sheet. The only other item you'll be allowed to have on your desk is your calculator. And again, I'm saying this over and over again, and still people who doesn't follow this last bullet, show your work. Even if you are not 100% sure that what you're doing is right, better to put at least some work on the paper. You can receive some credit, partial credit, than not put in and have the white page empty. You're gonna get a 0. Okay, so even if you're not 100% sure, always show your work. That also applies when you're 100% sure about your answer, but sometimes you make a mistake. If you put your work on the paper, I can also give you partial credit. Okay? Questions? Okay, so the next thing I want to do is to cover some of the problems as a review. So again, these problems are coming from your homework. I know you have a homework due today. Again, as I did in the last exam, I'm not going to collect it this time because you're not going to have enough time to get your homework back by Wednesday. So I'm going to post the solutions today. If you have questions about your solutions or you don't understand something about the homework, I'm going to cover some of the homework problems here in class today. But if you still have questions, I'm going to be in my office tomorrow. So just stop by, send me an email. We can set up an appointment. Okay, and also I'm going to be in my office this afternoon after the lecture. So this is problem 340 from your homework, and this problem in particular is about joint probability distributions, chapter 3. And here what we have is a fast food restaurant that operates a drive-through facility and a walk-in facility. Okay, so we're going to use a random variable to model each type of facility. So on a randomly selected day, we have X and Y, two random variables. X will be the proportions of the time that the drive-through and walk-in facilities are in use. So X is for the drive-through, Y is for the walk-in. Suppose that the joint density function of these random variables is given by f x y, and you have the function here, and that function is defined for this range for x and y. So the first question is, find the marginal density of x. So we want to find the marginal distribution. We have a joint distribution. This is a continuous distribution. So we have, let me call the marginal of x, g of x. So what would you do? 0 to 1 of the joint with respect to x or y? Correct. Everybody's following. So we want the marginal of x. We integrate with respect to y, and we use the range corresponding to y. which is, in this case, is both are the same, but for y is from 0 to 1. So if you solve this integral, you get 2 over 3 x plus 1, and this is for x within 1 and 0. So part B is essentially the same thing, but in this case you want a marginal for y, so I'm going to call that h of y. So what will be the limits?
0 to 1.
Correct. You have the same joint, but in this case you need to integrate with respect to x. So if you integrate this, this is 2 over 3, 1 plus 4y, and this is for y within 0 and 1. Questions? So what we are doing here, we have a joint density function, and we want to find the marginals for x and y. So let me write something here, just to remind you that x is representing the drive-through, and y represents the walking. So the part C is asking, find the probability that the drive-through facility is busy less than 1/2 of the time. So here we are referring to random variable x, which corresponds to the drive-through facility. So in order to find that probability, we have to use the density function, or the marginal density function, or x, which corresponds to our random variable x. So the probability is busy less than 1/2 of the time. So is the probability of x less than 1/2. And what would be the integration here? 0 to 1/2 of 2 over 3 x plus 1 dx. Anybody understand why we're using this? Because this is the marginal distribution corresponding to x, and we want to find the probability that the drive-through facility is busy less than 1/2 of the time. X represents that random variable. So we use the marginal for x. We solve this, and this equals 5 over 12. Okay, so we went from the joint, we found the marginals, and we find the probability corresponding to one of the random variables, x, in this case. Questions? Yes, sir.
This can stay on the part B.
That, you didn't get the same.
I got 1/3.
Oh, yes. Let me see. Yes, it's 1 over 3. That's correct. So this should be 1/3. Thank you. Thank you. Any other question? Okay. So this is the type of problem that you can expect from the joint probability distributions. Find the marginals, find the probability for one of the random variables, and so on. Okay? Can I move to the next slide? Okay, so in this problem, this is for the mathematical expectation lecture. So here I have for lab assignment, if the equipment is working, the density function of the observed outcome x is provided by that density function, which is continuous. And I'm asking what is the variance and the standard deviation for that random variable. So the random variable is described by this probability distribution, which is continuous. And I want you to find the variance first. So before we get to the variance, let me give you the formula. So there's two ways that you can find the variance. I'm going to be using this formula, which is the expectation of x squared minus the mean square. Okay, so that's the formula that I'm going to use. So as you can see here, you need two things in order to find the variance. You need to find the mean, correct? And you need to find the expectation of x squared. So let's start by finding the mean. So mu equals e of x. And how do you find the mean for a continuous random variable? Correct. So it's the integration of x times f of x. And remember, this is for continuous, but when you do for a discrete case, you need to look at the sum. So in this case, the formula is from minus infinite to infinite f of x times f of x dx. Okay, so that's the general formula. Now we're going to apply that formula to this problem. So you have the integration from 0 to 1, x times 2 times 1 minus x dx. Is that clear? Okay, so the only thing you have to do is to multiply your density function times x and then solve the integration. So in this case, we have this is equal to 2 from 0 to 1 x minus x squared dx. And solving this integration, you get 1 over 3. Okay, so we are trying to find the variance. In order to find the variance, we need to find the mean. Okay, so we have the mean. Now we have to work with this part of the formula, which is the expectation of x squared. So the expectation of x squared is also the integration from minus infinite to infinite. So what will be the expression for that integration? Correct. So it is x squared times f of x. Okay, so look at the first expression. It's just for 1x. So you multiply f of x times x. Here is x squared. Your random variable is squared. So you multiply your probability density function by x squared. So if you solve this, you'll get from 0 to 1 x squared to 1 minus x dx. And this is equal to 2 the integration 0 to 1 x squared minus x cubed dx. In solving this, you get 1 over 6. Okay? So now we have everything we need to get the variance. So the variance equals 1 over 6 minus 1/3 squared. and this equals 1 over 18. What will be the standard deviation? Correct. So the standard deviation is the square root of 1 over 18, which is 0.2357. Okay, so again, these problems are coming from your homework. I'm just discussing them in order to see if you have questions and also to review the material. So this corresponds to the material for the mathematical expectation and the variance. So here we are finding the variance and the expectation for a continuous random variable. Okay? So the concept, you should be clear about how to get the expectation from a continuous random variable. So you need to find the integration of x times f of x. And also, you need to know how to get the variance. So remember, in order to get the variance, you need to find the expectation of the random variable. And that's what we did. We also find the expectation of x squared, and then you plug those results into the formula for the variance, get the variance and the standard deviation. Questions? Okay. So now we're going to transition to the next topic we cover in class, which is the discrete random variables and discrete probability distributions. This is problem 5.5 from your homework. And here we have an experiment in which approximately 30% of all pipework failures in chemical plants are caused by operator errors. So we have a probability here. Should be able to identify that probability. So 30% of all pipework failures in chemical plants are caused by operator error. And the first question is asking, what is the probability that out of the next 20 pipework failures, at least 10 are due to operator error? So we are looking at the next 20, and we want to find out that at least 10 of them are identified as successes. In this case, a success is that the failure is caused by the operator. So you have the next 20 trials, and you want to know that at least 10 are successes. What type of distribution is this one? Correct. So we need to use the binomial because we are looking at the number of trials that result in a success. So we are looking at the next 20, 10 of them, what is the probability that 10 of them result in a success? So the first question is, what is the probability that out of the next 20 pipework failures, at least 10 are due to operator error? So we know this is a binomial. What is the value of P? 0.3, because that's your probability, 30%. Okay, so 30% is your probability. What else do we need for the binomial? We need the value of n. How many trials are we looking? 20. So n is 20. And those are the only two parameters that we're going to need. N and P. And now we want to find the probability. So for part A, it is asking that at least 10. So what is the probability that we are looking at? The probability of X being less than, equal, greater than? Correct. So it's greater or equal to 10. And we know that we will see this type of probability, the best thing to do is to find the complement. Okay, so it's going to be easier to solve, especially if you're looking at the table of the binomial. You know that it's going to give you the cumulative from 0 to whatever number you're looking at. So you need to look at the complement. So this is the probability of 1 minus the probability of X being less than or equal to 9. Okay? So this is 1 minus the summation, because this is discrete, from X equals 0 or 1. 0 or 1? 0. So you have to include 0 to 9. Of the binomial. So I'm going to use this binomial X, 20, and 0.3 is the probability. So if you go to the table, you'll find that this probability equals 0.952. So that probability equals to 0.048. Okay, so you can find this probability in table A2 from your textbook, or you can also solve this by hand. My recommendation is, for the exam, just try to make use of the table, because it's going to save you some time. And remember, the table is going to give you the cumulative. So if you, yes sir?
Can we use the table? Or is it going to be already one?
I'm going to give you the table. Yeah, I'm going to provide the table. Yeah. For the binomial and the normal distribution. Okay? So, just be aware of this. You can also solve it by hand. Okay, so part B. What is the probability that no more than 4 out of 20 such failures are due to operator error? So what would be the probability in this case? Correct. So it's less than or equal to 4. So do the same thing. This is the summation from X equals 0 to 4 of the binomial X 20 0.3. So this equals 0.2375. Yes, sir. So in that case, you will require to use the expression for the binomial. Let's see if I have it here. What I recall, let's see if I can. Yeah, I don't want to give you the wrong formula, so let me find it here. Okay, so this is the expression. It's nx px 1 minus p n minus x. So what you have to do is the following. For this case, you're going to have to, right there, this is going to be n equals 20 for x equals 0. The probability is 0.3 to the power of 0, 1 minus 0.3 to the power of n minus x, which is 20, plus 21, 0.3 to the power of 1, 1 minus 0.3 to the power of 19, plus 22, 0.3 to the power of 2 times 1 minus 0.3, 18, plus 23, 0.33, 1 minus 0.3, 17, and we go up to 4. So let me add number 4 here. So it's 24, 0.3, 4, 1 minus 0.3, 16. So as you can see, this will take some time to solve. This is, yeah, this is the combination formula. So it's, yes, it will give you this. But if you use the table, you can find this right away from table A2. Yeah, for the binomial. So it's table A2. Make sure that you find it, A2. So you're going to have a table for different numbers of observations. In this case, you have 20. You have to find the table for 20. Make sure that you have the binomial. Anybody else having trouble with the table?
For the providing the A2.
Yes. So I can show you the table here. Let me. So
Happy trees.
so do you have the page from the textbook? Let's see.
Table A1.
Okay, so this is the table for the binomial. Yes, and it's table A1. So you will see that here you have probabilities tabulated, and this corresponds to the number of observations that you have. So in this case, you have n equals 8, 9, 10. For this problem, we have to find n equals 20. Okay, so we have n equals 20. The only thing that you need to know is the probability. So in this case, we have the probability equals 30. So at the top of the table, you'll see different probabilities. You're looking at the fourth column for n equals 20. So let's go down. The fourth column, and for x equals 4, it's going to be 0.2375. Okay? So that's the cumulative for the binomial. So again, you're going to have different number for n, different tables. In this case, we have n equals 20, so you look at 20. Each column represents a different probability. This second column represents the number of successes. So in our case, we have 4. So we look at row 4. The probability is 0.3. So this is the probability that we are looking at. Any questions? Okay. So let's go back to the problem. So that's why I recommend you to use a table, because if you put this expression, it's going to take you some time to solve the problem. Okay, so the last part is, suppose that a particular plant, that out of the random sample of 20 such failures, exactly 5 are due to operator error. And then I ask you another question. Do you feel that 30% figure stated above applies to this plant? So first we need to find the probability of x equals 5. So let me see if I have some space here. So I'm going to write that probability here. Oops. So this is part C. The probability of x equals 5. So in this case, maybe it will be better to use the formula, but you can also solve this using the table. And I'm going to show you how. So the probability of x equals 0, you're referring to a binomial with x equals 5, where we have 20 observations and the probability equals 3. Okay, I think this is a very good exercise, because it's going to clarify some errors that you can have using the table. So now we want to find the probability of x equals a number. Okay, so in this case it's equals 5. So if you use a table, let's go back here. We have that for x equals 5 and 0.3, that will be 0.4164. This number is that the number that you will use? Right. This is the probability of x being less than or equal to 5. So that includes 0, 1, 2, 3, 4, and 5. You only want the probability of x equals 5. So you need to subtract this cumulative distribution, or the probability of x being less than or equal to 5, minus the probability of x being less than or equal to 4. And that will be, see? So the first way you can solve this is the following. You can just say 20 and 5, 0.3, 5, 1 minus 0.3, 15, and that will give you 0.1789, or you can use the table. And you need to find the probability of x being less than or equal to 5 and subtract the probability of x being less than or equal to 4. So for x less than or equal to 5, we have 0.41 something. 41. Does anyone have that number? 4164. And for x less than or equal to 4 is 0.2375. So if you subtract this, this is 0.1789.
Will you post all this?
Yes, I'm going to post this. Okay. So you will have these slides with the solutions. Okay, so two different ways. Again, here it's just the probability of x equals 5, so it's very simple. Solve this. Not the same case here when you have to consider multiple. You can also use a table. You just have to subtract the cumulative to get the probability of x equals 5. Questions? Okay, so here we're using the binomial, and we are looking at the number of trials that result in a success. Okay, so let's move to the next problem.
So the answer is no.
Oh yeah, so this is the, yes, forgot about the next question. So we have 0.1789, and the problem is telling you that is 30% the probability that they are using. So do you feel that 30% figure stated above applies to this plan when you find that that probability is 0.7? Well, in this case, I think you can make a case. There's a difference, but it's not a significant difference. I mean, the probability is about 20%, so I would say is maybe how risk averse you are. It's 0.20 compared to 0.8. It's close, but it's not that close. So if you feel that you're very risk averse, you might say that that's not a good estimate. Okay? You can make a case for both cases. Any questions? Okay. So let's move to the next one. A random committee of size 3 is selected from 4 doctors and 2 nurses. Write the formula for the probability distribution of the random variable x representing the number of doctors on the committee. And then also find the probability of x being between 2 and 3. Okay, so here we have that we are choosing or selecting a committee from within the group. So the actual group is 6, 4 doctors, 2 nurses, but we are selecting a smaller group from that group, and we're going to make an inference about that group. Any idea what type of distribution is this one? Correct. This is a hypergeometric. So every time that you see that you are making an inference from a smaller group, you're basically sampling without replacement. You're taking a small sample from a group and making an inference from that small sample. That's hypergeometric. So in this case, let me write this. X is the number of successes in the sample. And this is hypergeometric. Okay? So for the hypergeometric, you need to identify 3 parameters. And these are K, N, and small n. What is capital N? Is the size of the group. So this is 6. Then you want to choose 3 from that big group. So n equals 3. And how many of those 6 are categorized as successes? 4. Okay? So you have 4 doctors among the 6. And the question is the probability of the random x, variable x representing the number of doctors. So the number of successes represented by a random variable x, number of doctors, is 4. You have 4 of those x random variables. So k equals 4. Okay? So if you are able to identify the distribution and these parameters, then you should be able to solve the problem. Okay? So the first thing we have to do is to write the formula. Okay, so we know it's hypergeometric. So we can use the formula of the hypergeometric to write the formula. So for P equals X, we have a hypergeometric with X, capital N, and K. And we know that that is equal to K X n minus K n minus X divided by n choose n. So this is the probability for x equals x, or a number, using the hypergeometric. So for the formula sheet, you can write the formula for the hypergeometric and say k is this, n is this, and capital N is this.
Do we have that?
Yes. Okay. So you have the formula and the parameters. Okay. The one thing that I want to see is this. You should know when to use the hypergeometric. You should know when to use the geometric, when to use the binomial. Okay. But the formulas you can have. Yes.
Can you clarify what you meant by you don't want to see hypergeometric right now next to the formula? Is that what you mean?
Well, what I want to see is that when you use the hypergeometric.
Okay.
Yeah. You can have the formula. You can have the parameters k, x, but not when to use it.
Oh, okay.
Okay.
You don't write hypergeometric next to the formula.
No, you can write hypergeometric, but not like the description of when to use it. Okay? So now that you have the formula, it's just substitute the values for this case. So this is 4x n minus 3. So this is 3 n minus x. So this is 3 minus x, and it's 6 and 3. So for this case, this is the hypergeometric formula. Okay? Now, part B is find this probability, the probability of x being within 2 and 3. So, how would you solve this? For the hypergeometric, I believe we don't have a table. Yes?
Should that be 2 minus capital minus 2 over 3 minus 7 instead of 3 over 9?
This one? Yes, you're right. That should be a 2. Thank you. So for the hypergeometric, we don't have the cumulative or tabulated table. Okay, so in this case, you're going to have to solve using the formula. So we have the probability of being within 2 and 3. So that's the same as saying the probability of x equals 2 plus the probability of x equals 3. Right? Because both of them are included on those intervals. So if we solve this, you'll have 4 choose 2, 2, 3 minus 2, divided by 6, choose 4, plus 2, 3 minus 3, 6 and 4. And this is equal to 4 over 5. So this one corresponds to x equals 2. And this one corresponds to x equals 3.
Is that 3?
Again?
It's 3.
Oh, yes. Sorry. 3. Okay. Questions? Okay. Can I move to the next problem? Still on the discrete probability distributions. So the next problem is find the probability that a person flipping a coin gets the third head on the 7th flip and the first head on the 4th flip. So the third head on the 7th flip. What type of distribution is that one? So we want to know these many successes, 3, by these tribes. This is a binomial, geometric, negative binomial. Correct. It's negative binomial. In a negative binomial, you have your kth success occurring on trial x. So 3 occurring on 7, 5 occurring on 12. That's the type of question that you need to answer with the binomial, negative binomial, I'm sorry. So this is negative binomial. So for the negative binomial, we have x, k, and p. And this is equal to x minus 1, k minus 1, p to the power of k, q, x minus k. Where k is the number of successes and p is the probability. So what is the probability in this case? So we are going to assume that we can have a fair coin. So we have the same probability for getting a head or a tail. So it's going to be 0.5. And what will be the number of successes? Correct. Okay. So for this case, we have x is going to be equal to 7 by the 7 flip. So we have 7 minus 1. K is 3 minus 1. 0.5 to the power of 3. And this is also 0.5. X minus k, 4. And this should be equal to 0.1172. So again, part A, this number of successes by this number of trials. Part B, the first head on the fourth flip. The first success by the fourth flip. This is negative binomial, binomial, hypergeometric, or geometric. What was that? So every time you see the first success, that means that this is a geometric. Every time you look at problems and ask you for the first success in this number of trials, that is a geometric. So this is a geometric because we are looking at the first success occurring on trial X. Can you see the difference between A and B? At least you see that difference? This many, 3, 4, 5 in these many trials. The second one is the first in these many trials. That's the main difference between these two. So,
Can you say that again?
yes. So for this problem, this specific problem, we have two different scenarios because we are asking two different things. Okay? On the first one, the first part, we are asking the third success. So we need to have 3 in these many trials. So in this case, it's 3 successes in 7 trials. When you see such type of question, that means that it's a negative binomial. It could be 4 in 7. It could be 5 in 100. Is the type of question.
We're assuming the success.
The problem is telling you how many successes.
Right.
But it's giving you a specific number. In this case, it's 3, but you want to achieve those 3 successes in 7 trials. That's the type of problem that we're trying to solve.
We're assuming there's already been 2 successes. What is the probability of the third?
No.
Okay.
Well, you're going to have 1 and 2 to get the third one. Yeah, so, but you want to be able to have all of them by this specific number of tries. So in this case, you want to have 3 in 7. Okay? It's like if you look at the finals in baseball. You want to predict what will be if you can win the finals in 6 games. You want to know you're going to have 4 successes in 6 tries. Or what will be the probability of winning the World Series in 4 games? That's another probability. 4 successes in 4 tries. That's the type of question that we are solving. Now, the second question is the probability of having a success in this trial. Let's say, same example, you want to know if you want to win the first game by the third game, or by the second game, or if you're going to win the first game on the first game. Just looking at the first success. Okay? So that's the geometric. So for part B, the first head on the 4th flip, you have, for the geometric, you have g of x and p, and the function is pq x minus 1. So in this case, we have x equals 4, so g of 4, and the probability is 0.5, so it's 0.5, 1 minus 0.5 to the power of 3, so this is 1 over 60. You should be able to get the same answer. Yes.
Be just like 3, 2, 0 times. Okay.
That's a good question. So if you try to solve this with the negative binomial, you can get the same answer. Okay, so the last problem for this section, or for this material, corresponds to the last discrete probability distribution that we covered in class, which is the Poisson. See. I think I'm skipping one. Yeah, I'm gonna skip the other one, and I'm gonna go to the Poisson. This is very similar. This problem is very similar to the one we solved. So let's look at this one. Okay, so we have changes in the airport. Procedure required planning. So we have arrival rates. So every time you see arrival rates, you most likely are dealing with the Poisson process or Poisson distribution. So an important factor that must be taken into account, suppose that a small aircraft arrives at a certain airport according to a Poisson process. So this is telling you that it's a Poisson process. And you have the rate, 6 per hour. What's the meaning of that rate? What is the meaning of that rate? Does that mean something about the Poisson? That's the mean, correct. It's the mean of the Poisson. It's 6 arrivals per hour. Thus, the Poisson parameter for arrivals over a period of hour is mu equals 60. So that 60 is the value of lambda, or mu, which is the mean. So the first question is, what is the probability that exactly 4 small airplanes arrive during a period of 1 hour? So the most important thing about this Poisson type of problem is that you have to be careful with the time units. So this is giving you the arrival rate in terms of hours, so you need to be sure that you're answering the question in terms of hours. If the question is in terms of minutes, you're going to have to modify your arrival rate. But in this case, there's no problem. You're looking at 1 hour period, so we can solve this using our mean in hours. So the first question is, what is the probability that exactly 4 airplanes arrive during a 1 hour period? So A is looking at the probability of X equals 4. Exactly 4. So X equals 4. And we use the Poisson. So we know it's E to the minus lambda T. Lambda T. And then you have lambda T X divided by X factorial. That's the Poisson. So lambda T 6. Well, here we're using mu, so this should be mu T equals 6. So we have e to the minus 6 times 6. X is 4 and 4 factorial. So if you solve this, this is 0.1339.
Where did that mu t equals 6 come from? Shouldn't it be mu t or sorry?
So yes, I'm confused. This is kind of confusing. So let me change lambda by mu. So this is mu and mu. T. So mu equals 60. So in this case we have mu t, we have mu equals 60, but the time period is hours, so we don't have to modify it. Part B is what is the probability that at least 4 arrive during an hour period. So part B, we are looking at least. So what is that probability? Less than, greater than, equal to? Correct. So every time you see a greater or equal, it's better to look at the complement, because if not, you're going to have to go to infinity, from 4 to infinity. So it's just better to look at the complement. X. So now you just have to find the probability from 0 to 3. And then subtract 1. So if you do this, you will get 1 minus e minus 6, 6, 0, 0 factorial, plus e to the minus 6, 6, 3, 3 factorial. And this is going to be equal to 0.8488. So you have to find from 0 up to 3, and then subtract 1 minus that. And now this is what I was referring to when I said that you need to be careful with the time units. So now we want to change from hours to days. Okay? So if we define a working day as 12 hours, what is the probability that at least 75 small aircraft arrive during a working day? So in our case, in this case, a day is going to be represented by 12 hours. So we need to change our time units from hours to days. So you know that we are going to expect 6 airplanes per hour. So if you want to move that or change that to days, in this case, you're going to have to multiply that times how many hours? 12. So your new mu equals 6 times 12. So this is 72. And the question is the probability of x being greater than 75. It's part C. You look at the complement, 1 minus p x less than 75. And for this type of problem, that at least 75, yes. 75 greater or equal to. That's correct.
And then that would be 7 plus everything, 74.
This one is the same.
It's the same thing.
Yeah, because you don't have the inclusive there. So you can do less than or equal to 74. It's going to be the same. Okay, for this problem, I cannot ask you to solve this in the exam. You have to go from 0 to 74. That will take you a day. Okay, so what you can do if I ask you something like this is just write down the expression, and most likely I'm not gonna ask you something like this, but for the purpose of the example, you can put this 74 e to the minus mu t x factorial. Okay? This is the expression for this. Questions?
So about the summation, though, is it n minus 1?
Here?
Yeah.
Well, in this case, you don't want to include 75 because it's less than. So that's why you go from up to 74. Yes. Okay, so I don't have time to cover the normal. If you have questions about the normal problems, you can see me. I'm gonna be in my office, or you can see me tomorrow. I'm gonna post this today. I'm gonna also post the solution for the homework today. Let me know if you have questions, and I'll see you on Wednesday. The homework is here. Previous homework, if you want to pick your last homework, it's graded, it's here.
One with the 49.